Let's take the derivative of the following function using the chain rule. Don't forget that from our previous class, I told you the chain rule can be expressed mathematically as dy over dx is equals to dy all over du multiplied by du all over dx. Okay? So now, let's proceed with question number 1. We have y is equals to what? Tan 3x plus 2. Y is equals to tan 3x plus 2. The first step is that we're going to set the inner function equals to u. So u is equals to what? 3x plus 2. Okay? So definitely y will be equals to what? Tan u. So the next step is that we're going to differentiate both functions. Okay? So the u over the x is equals to what? 3. You understand? And the y over the u is equals to what? If you differentiate tan x, you are going to get what? Sec square x. Okay? So if you differentiate tan u, you are going to get sec square u. So this will be what? Sec square u. Okay? Now let us proceed. Don't forget, according to chain rule formula, this is the mathematical expression. Okay? So dy over dx is equals to dy over du. dy over du is what? Sec square u. So I'm going to have sec square u multiplied by du over dx. Du over dx is 3. So that will be what? 3. So dy over dx is equals to 3 sec square u. Okay? So therefore dy over dx is equals to 3 sec square. Now don't forget that u is what? 3x plus 2. You understand? So I'm going to substitute 3x plus 2 as u. So the derivative of y is equals to tan 3x plus 2 is what? 3 sec square 3x plus 2. You understand? So let's proceed to the second question. We have find the derivative of y is equals to in x. Now, I want you to pay attention. I have not taught you how to differentiate a function that has an Euler's constant before. So please, I want you to pay attention. When you are told to differentiate a function that has an Euler constant e, which is raised to the power of an exponent, the first step is that you are going to set u is equals to the power of the exponent. You are going to set u is equals to the power which the Euler's constant is raised to. Now look at this. What is the power to which the Euler's constant is raised to in this equation? Euler's constant is raised to the power of x. Is that not it? So I'm going to set u is equals to what? X. Please, it is very, very important that you master this because these are the basic principle of differentiation. Okay? So you have set u is equals to the power to which the Euler's constant is raised to. Definitely y will be equals to what? E raised to the power of u. Do you understand? So now I'm going to take the derivative of u and y. So let's take the derivative of u first. Derivative of u, which is what? Du over dx is equals to what? 1. Now let's take the derivative of y is equals to e in u. Dy over du will be equals to what? In u. What I did is this. If you differentiate e's, that will be 1. 1 multiplied by in u, that is what? In u. You understand? So please, I don't want you to get confused at all. Okay? It's very, very simple. Just follow the procedure. Now let's take dy over dx will be equals to dy over du. Dy over du is what? In u. In u multiplied by du over dx. Du over dx is 1. So multiply by 1. So dy over dx is equals to in u multiplied by 1. That is what? In u. So dy over dx is equals to e raised to the power of, don't forget that u is equals to x. So I'm going to replace u as x. So dy over dx is equals to what? In x. That is why we call this what? Standard derivative. Anytime you differentiate in x, you are going to get what? In x. This is one of the standard derivative. Okay? So let's proceed to the third question, which is y is equals to e raised to the power of 3x plus 2. To take the derivative of this function, you can see that this question number 3 look like question number 2. You can see only that the power is not the same. So I want to use this to explain better. The first step is that you are going to set u is equals to the power to which the Euler's constant is raised to. So u will be equals to what? What is the power to which e is raised to? E is raised to the power of 3x plus 2. So u is equals to 3x plus 2. Therefore, y will be equals to what? E raised to the power of u. You understand? So now, the next step is that we are going to take the derivative of u and what? Y. So the u over the x will be equals to what? 3. And the y over the u will be equals to what? In u. You understand? Anytime you differentiate e raised to the power of any letter, maybe e raised to the power of a, that will be what? In a. E raised to the power of x, that will be what? In x. E raised to the power of z, that will be what? In z. E raised to the power of y, that will be what? In y. You understand? Anytime you differentiate e raised to the power of any maybe a single letter, that will give us the, it also give us the same result. You understand? Okay, let us proceed. The y over the x is equals to the y over the u is what? In u. In u multiplied by the u over the x. The u over the x is what? 3. So in u multiply 3. The y over the x is equals to 3 e raised to the power of u. Do you understand? So I'm going to substitute the u. That will be what? 3 e raised to the power of u is what? 3x plus 2. That will be what? 3x plus 2. Do you understand? Please, I skip a step here. That is, I didn't write this formula. That is the y over the u. The y over the u is what? In u, as you can see, multiplied by the u over the x. The u over the x is what? 3. Abi? So therefore, the y over the x is what? 3 e raised to the power of u. So I substitute the value of u as 3x plus 2. Now, you can see that there is something similar to when we take the derivative of this second question. Anytime you are told to differentiate a function that has an Euler constant, for example, let's say we are told to differentiate y is equals to e raised to the power of 2x. Just take the derivative of the power to which the Euler's constant is raised to and multiply it by the coefficient. That's the derivative. Do you understand? So now, derivative of y here will be what? 2e raised to the power of 2x. If you follow this long approach, you are still going to get this answer. I get what I'm saying? You are still going to result into this answer. Anytime you are asked to take the derivative, let's say we are asked to find the derivative of e raised to the power of 2x plus 1. The derivative of this will be what? Just differentiate the power to which the Euler's constant is raised to and multiply it by the coefficient. So derivative of y will be what? Differentiate 2x plus 1, that's what? 2. So 2e raised to the power of 2x plus 1. Do you understand? So it's very, very simple. Let's say we are asked to differentiate y is equals to e raised to the power of 4x, e raised to the power of 4x. The derivative of y will be what? 4e raised to the power of 4x. Do you understand? Let's say we are asked to differentiate y is equals to e raised to the power of 2x squared plus 1. The derivative of y will be what? Differentiate 2x squared plus 1 using the power rule. You are going to get what? 4x. So this will be what? 4x raised to e raised to the power of what? 2x squared plus 1. Do you understand? Just anytime you are asked to differentiate a function that has an Euler constant, just differentiate the power to which the Euler's constant is raised to, then multiply it with the coefficient. That is how we are going to get the derivative of the function. So now, I want you to pay attention. If you follow the long approach that I used the previous time, you are still going to get the same answer. You can try it. Try the long approach and check whether you are going to result into this answer. Use it to differentiate this 1, 2, 3 and check whether you are going to get this answer. Okay, let's proceed to question number 4.